Hey Math 85, this is Dr. McGaffey, and we're starting section 8.3, which is solving equations where we're using both addition and subtraction properties of equality and also multiplication division properties of equality. Also, we might have variables on both sides of the equation. Okay, so before we start, I just want to go over the order of operations. So remember that first we start with parentheses, and then exponents and roots, and then we go to multiplication and division, and we perform those operations in the order that we see them, left to right, and then addition and subtraction, and we perform those operations in order that we see them, left to right. So when we are evaluating, we will do things in this order. But when we're solving equations, we have to start undoing these operations. So when we're undoing these operations, we start with the most simple and we work our way back. So when we're solving, first I'll undo any addition, subtraction that I see, and then any multiplication and division. Okay? So let's just remember that when we're solving, we kind of go in the opposite order of the order of operations, because we are undoing those things. All right, so first we will simplify both sides of our equation and then collect all variables to one side of the equation, and then solve using the addition and subtraction and multiplication division properties of equality. Let's see how that works in this first example. 4x plus 6 equals negative 14. Again, every time I see the equal sign, I imagine that splits my workspace into two sides. I've got 4 times x plus 6 on the left-hand side here. So notice I want to move all of these numbers, the 4 and the 6, over to the other side so that I'm left with just the x here. So first I'll undo the plus 6 by performing minus 6 to both sides. So here I'm left with 4x equals, and negative 14 minus 6, or plus negative 6, gives me a negative 20. All right, now that I have that moved over, now I can work on undoing this multiplication. 4 times x. I'll divide both sides by 4, and I'm left with x equals a negative 5. And then we can always check our answers by plugging the solution into the original equation. So 4 times negative 5 plus 6. Want to see if that's equal to negative 14. We'll do the 4 times negative 5, which is negative 20, plus 6. Negative 20 plus 6 is negative 14. And it all checks out. All right, let's do the next one. 2y minus 7 equals 15. Here's my two sides of the equation. First, I'll undo the minus 7 by adding 7 to both sides. This gives me 2y equals 15 plus 7 is 22. Now I can undo this multiplication. 2 times y, divide by 2, both sides. And I get y equals 22 divided by 2 is 11. You can always check your work. Let's look at the next problem. This one has a variable on both sides of the equation. So 5x equals 4x plus 7. First, I'll see if there's anything that I can simplify before I start manipulating things from one side to the other. And it's not that both sides are simplified as far as they can go. So now the 4x, I would like to combine the 4x to the other side of the equation. So I need to undo whatever operation is connecting the 4x to the rest of the terms on this side. So it's addition is the operation, 4x plus 7. So I will subtract 4x from both sides. So think of it as 4x plus 7 minus 4x. When you combine these two terms, they add to 0. That goes away. So what I'm left with on the right is just 7. And here 5x minus 4x is 1x, which I'll just write as x. And there is my answer. And then we can always check our solution. 5 times 7 equals 4 times 7 plus 7. Let's see if that is true. 5 times 7 is 35 equals 4 times 7 is 28 plus 7. We've got 35 equals 28 plus 7 is indeed 35. So it becomes true. Great, so I know now that x equals 7 is my solution. Let's look at this equation. 5y minus 8 equals negative 7y. So you've got a few choices here. You can move the negative 7y to the left, or you can move the 5y to the right. I think what I'd like to do is move this 5y to the right-hand side, because then I'll have less terms on one side of the equation. But it doesn't matter. So what I'm going to do, 5y minus 8. Notice this is a positive 5y, so you can think of this as being plus 5y minus 8. What I'll do is I will subtract 5y from both sides. (5y minus 8 minus 5y), these two add to 0, which leaves me with a negative 8 on the left, and negative 7y minus 5y is equal to negative 12y. And now I can solve for y by undoing this multiplication, negative 12 times y. So divide both sides by negative 12. Right? Negative 8 divided by negative 12. Now, that doesn't divide evenly, so I'm going to leave it as a fraction, but I should simplify that fraction. Negative divided by negative, that'll be positive. And is there a factor that goes into both 8 and 12 so that I can simplify this fraction? And we should recognize that 4 goes into both 8 and 12. So 8 divided by 4 gives me 2. And 12 divided by 4 gives me 3. So this is 2/3. And again, remembering this is positive because it's negative divided by negative. All right, so it's 2/3 on the left. And over here, right, the 12s go away because negative 12 divided by negative 12 is leaves me with just y. So y equals 2/3. And then you can always check your answer. Let's do a few more problems here. Here I've got 7x equals negative x plus 24. I, again, like to visualize that I have two sides that I'm dealing with. So this is a negative x plus 24. So in order to manipulate so that this x appears on the other side, I will add x to both sides. Minus x plus x. That adds to 0 and leaves me with just 24 on the right. And 7x plus 1x is 8x. 8x equals 24. Now I'll undo this multiplication by dividing both sides by 8. Leaves me with x equals 3. All right, let's do another one which is a little bit more complicated. Again, I've got x's on both sides of the equation here. 7x plus 5 equals 6x plus 2. What I'd like to do is subtract 6x from both sides so that I don't have any more x's on the right-hand side here. So minus 6x. And though I like to line things up with the like terms that I'll be adding or subtracting from. So 7x plus 5 minus 6x. These two can be combined. 7x minus 6x is 1x. I'll just write that as x. Plus 5 equals, and on the right hand side here I just am left with 2. Now I can solve for x by undoing this addition, so minus 5 to both sides. X equals negative 3. Let's do these last two problems here. I've got 6n minus 2 equals negative 3n plus 7. So notice both sides are simplified as far as I can go. I need to manipulate it so that I have only n on one side of the equation. So in order to do that, I will do the opposite of this minus 3n. I will add 3n to both sides. lining like terms up underneath each other. So 6n plus 3n gives me 9n, and then I still have that minus 2. And the minus 3n plus 3n, those add to 0 and leaves me with just 7 on the right-hand side. Alright, so now I have 9n minus 2 equals 7. In order to solve for n here, first I'll undo this subtraction by adding 2 to both sides. This leaves me with 9n equals 7 plus 2 is 9. And now I'll undo this multiplication by dividing both sides by 9. So I'm left with n equals 9 divided by 9, which is 1. Alright, last problem for this video. 2a minus 7 equals 5a plus 8. Again, imagine that you have two sides to this workspace here. And I want to collect all of the a terms to one side. So this is plus, it's like, imagine this as plus 5a plus 8. So I want to move the 5a to the other side by subtracting it from both sides. Lining like terms up underneath like terms. 2a minus 5a is a negative 3a, and then I have that other term, minus 7. And on the right-hand side, 5a minus 5a adds to 0, which leaves me with just the term 8. Now I can work on getting a by itself by first undoing the minus 7. So I'll add 7 to both sides. So on the left I have negative 3a, and on the right 8 plus 7 is 15. Last step is to undo this multiplication. So I'll divide both sides by that coefficient, negative 3. So I get a equals 15 divided by negative 3 gives me negative 5. You can always check your answer. You can stop the videos here and try all the homework that looks similar to the ones that we've done so far.